Yeah, one thing I was just going to say before that, we've printed out some evals. I've basically started handing them out at this side of the room, putting them by the benches. I kind of ran out when I got round here somewhere. We would really love your feedback. We really want to know, what you like about this conference. We would love to do it again next year, so we want to know, things we can do better next year. The list of sessions, they're not really in any specific order. We're really looking at the content rather than the presenter to think about what type of sessions you want next year. If you're over there and you haven't got an eval, there should be some spare ones. There should be enough, and wait until all of the sessions are done before you choose your top 5 content-wise. Okay, so good afternoon. My name's Alan Smith. I work for Active Solution together with Magnus and Robert, a team of other developers. I'm also sort of heavily passionate about working with cloud computing, Windows, Azure, and all of these technologies. What I'm going to be talking about this afternoon is some techniques that you can think about when leveraging the Windows Azure storage services for big data scenarios. I see a lot of opportunities coming for working with big data, and the services we've got available in table storage, blob storage, and the way that we can distribute load with the queues gives us some great scenarios that we can start to focus on. Mark Brown posted this tweet pic yesterday, something that was going on outside. No idea what was going on there. The first thing I saw, and this is probably why I'm a cloud geek, is I looked at that and basically says that pattern is not going to scale. You can maybe scale it out horizontally a bit, but the vertical scaling, that's not going to work. So thinking about scalability is important. One of the things I do with table storage on a very, very small scale is I use them for the training courses that I'm doing, the labs I do on the training courses. So what I've got is a very simple Windows Azure website. I've got the actual website running here, and I'm actually storing the content for the labs in blob storage. So if I go to the course content, I can sign in with a custom federation provider, which I've got here. Really simple user interface there. So I can sign on with LNS and my password, and basically sends back that security token and says I am registered on that course, and then I can access the actual labs. So if I go to the course lab, you can tell by my graphics design this is really pitched at .NET developers. And you go into one of the labs, and you can see it's a lab on the render farm, which is the demo I was doing at Cloudburst last year, being converted into a lab. So this is creating a high performance render from using worker roles. Yeah. So what you always find is, correcting the labs and making sure the students have an updated copy of the labs. One thing I can do here is go into the actual document, and here I've got the Words document for that particular lab. I can open that up in Word. I can right-click and change my spelling like this, basically save down the Word document. Then what I can do, I've got a content publisher, and this is this little Windows Presentation Foundation application. What I can do is click on this, and it basically uses the .NET Word interop to actually convert the labs into an HTML format. I can then load the labs and click on Publish, and it pushes these labs out into blob storage. And the actual blob container that I'm using here, if you go into the Storage Explorer, you can see the actual labs there, the HTML files. I've got the lab image files here, which are all the various images, and it basically, sorts out all of that publishing. So once I make a quick change to the lab, if students say, this step is wrong, you need to change that, I can make that change, and the students should be able to refresh the actual page and get the updated copy of the labs. Now, the reason I'm talking about that is when we think about the actual pricing for Windows Azure, because that's when it does start to become really interesting. What I'm doing here is I'm querying the storage analytics tables, which are fairly newly appeared in table storage. So I can see the actual daily cost that I'm using to consume this much of data with this many blobs in this many containers. And it's 1.4386 e to the minus 5 per day. Now, if you work out the annual cost that I'm using in blob storage, it comes out to ½ a cent to actually store that data. So some of the stuff that you can do with Azure makes it, a really great option to go for as far as the actual prices are concerned. But what about big data? I am not a big data expert. Andy Cross, who was speaking here yesterday, is a big data expert. And we were chatting on Skype the other night about big data scenarios. I was talking about what I was doing, and he was talking about what he was doing. And this is his definition of big data. Big data is distributed expression of computational logic over a complex data domain. And I was kind of saying, that's a lot of long words. For me, I'm, new to this. It's just lots of stuff that would be maybe hard or challenging to handle using various other techniques. Now, if you think about working with storing a lot of information on premise, it's challenging and it is expensive. You need to go start shopping for one of these, which is a disk array or storage area network, that type of technology. And when you found out how much one of these things costs, you need to go speak to your boss. They need to speak to the IT crew. They need to start dragging in lots of cables. And once you've got it up and running, it's going to start consuming resources, electricity, cooling, and so on. But you also may need to do replication. So you need a second server room, you need a second storage system. You need to talk to your boss about the actual budget and the IT guy and the wiring and all of the resources that this is going to be consuming. The delivery time on that is going to be measured in months. And it's going to take a long time to get that actually commissioned and up and running. And it's going to be tens or hundreds of thousands of dollars for these large-scale storage solutions to be able to do that type of thing. And an alternative is to go to Windows Azure. Windows Azure has all of the hardware already provisioned for you and all of that infrastructure. You don't need to worry about creating and purchasing stuff. You go into the Windows Azure portal, you create a storage account, you select the data center where you want that account created. And if you click on this, and this is enabled by default, enable georeplication, you will get georeplication in Europe between the two European data centers. The cost for doing a proof of concept, even if you're using a large data volume, if you're storing it for a few days, is going to be pocket change for some of the actual stuff that you're working with. And if you have an MSDN subscription, it's going to be free. So what does it mean, the actual cost for storing large data? You've seen my course storage for the images is basically, half a cent a year. And this is, when you start to get up to terabytes of data, roughly about $90 per terabyte per year. So if you've got an MSDN Universal, you get $150 of credit. So that's per month. So if you keep your storage account around all of the time, you can basically put about 1.6 terabytes of data in that storage account, have the georeplication, and that will be your $150 allocation. Now, if you want to do a bit of work and just push a lot of data in there and process it, you can put in 4.8 terabytes and have it hanging around for 10 days, or stick in 24 terabytes and have it present there for 2 days. You basically build per day on the actual capacity of the actual storage accounts that you're using. So the challenge that I had was thinking about Wikipedia. And basically, the scenario was I wanted to have something where I could be looking at using a lot of data, a lot of articles, a lot of words, or a lot of anything that I could be processing in Windows Azure. I also wanted it to be something that people could relate to. Everybody uses Wikipedia. Most people use it. I use it, several times a day for looking up stuff. There is currently about 4.3 million articles in the English version. There's a lot of content present in there. And the website is expanding, changing all of the time. Now, one of the great things about Wikipedia is it's very open source. So you can actually go to the Wikipedia site and you can download the Wikipedia data. So if I go into the big data folder, I've got this Wikipedia folder here. And what I've downloaded here is these XML files. Now, going into the data downloads, this is basically the Wikipedia content dump. And they basically do this on a monthly basis. There's, I think there's 27 XML files here, and if you look at the show more details section here, you can see that it's 42.1 gigabytes of actual XML data, which contains, the textual data for the articles. These aren't all the same size, so the smallest one is 147.5 KB. 147,000 KB. The largest one is about 10 gigs. So they're basically, differing in sizes there. The early articles tend to be in the first files, and the more recent articles tend to be in these files here. So what I was thinking about is, what can I do with this stuff? This is, if you think about data volumes, it's not really a really high data volume. But if you think about processing and thinking about complex processing tasks that we can do with it, then you do start to get some challenges. So the data set that I worked with was a previous version. I think I used the August data dump of Wikipedia. There was 4.3 million articles. When I went through and started analyzing the words in these articles, I got to about 27 million words. Now, when you're starting to build searches and search algorithms and stuff, it does get quite complex, and you start thinking about word stemming and word filters and stuff. Statistically, I think there's 250,000 English words in the English language, so there's a lot of combinations of words and made-up words and names and so, which is basically pushing it out to 27 million. I haven't really gone in and thought about how we can actually clean up that and reduce that number. And I built a text index search on it. The number of entries I've got in that text index is just over 1 billion. Now, that's not a coincidence. When you're working with building search filters, you basically have things that are called stop words. So the and of and at would be a stop word because it basically appears hundreds of times, and there's no point in going in Wikipedia and searching for the. It's not going to give you that much meaningful results. Well, you could search for the pop group, but maybe it's going to handle that slightly differently. Now, what I did was I started tuning the stop filter to get just over 1 billion rows. When I started on this project, I think the Gangnam Style was basically going up the charts on YouTube, and it was the first YouTube video to get 1 million hits. And I thought, well, 1 million's a lot of stuff. Let's see what happens with Azure table storage if we put 1 million rows in a table. Are we still going to be able to do that? Is it still going to be usable? The actual text content size, the size of the files that I'm parsing is 41.4 gig. It's not really big data in a volume perspective. So other big data scenarios where people are using Azure storage is when I think there's a project using MRI scans. When you do like an MRI scan in the US, there's a company that's basically storing these MRI scans in Windows Azure Blob Storage. And that's a huge volume of data that they're putting in. They're basically filling up storage containers, creating a new storage account, filling up that storage account. And the storage accounts take 200 gig of actual, 200 terabytes of actual data per storage account. And they're using multiple storage accounts for that. But my challenge was really, how can I process that data? How can I process it quickly? How can I get the data into table storage in a timely fashion? And how can I query that data and use that data to provide meaningful search results? So I'm going to actually kick off the demo because it does take a while for the actual demo to get up and running. So what I have in Windows Azure, if I go back to my Azure portal, is a worker role, a single worker role, which is basically running in the Windows Azure account there, and that's that Wiki Indexer account. Now, the worker role, I talked about worker roles a lot last year and did a big demo on scalability and so on. This worker role is listening to a queue, and it's going to be actually processing the transaction messages and doing the insert into table storage. Now, I'm not going to do the processing today with the entire content of Wikipedia. My aim, when I started, coming up with this session was I want to index the whole of Wikipedia in an hour. I haven't got the actual timing down to that. Might be something to aim for in the future. But what I'm focusing on really is just this actual first content file, which contains about 4,500 articles. I think it will generate about, I'm not sure how many actual words or how many indexes it generates, but I think it generates over 1 million actual inserts into table storage, but we'll see those actual statistics. So what I'm going to do is to go back to the Visual Studio project. I've got a console application here, and that's basically going to perform a couple of actions. The first thing it's going to do is it's going to actually create the index jobs. Now, to save time, I'm not actually uploading all of the index files into blob storage. I'm just going to basically place messages on queues, and I'll talk about how the process works once I've got this process started. Now, once those jobs have been created, I'm also going to monitor the worker roles. I'll talk about that a bit later on, how we can get an idea of actually what's going on in Windows Azure. So I'm going to do an F6 to build this. That seems to be fine, and Control F5 to run this. So what this is going to do is it's going to place 300 odd messages on a queue for the 300 odd actual index files that we're going to be inserting, and you can see the messages that are going on there. I'm going to leave that running a bit, so it's just going to actually start processing and working on the actual data, and I'll talk a bit about how the process works. Before I do that, one thing that I will mention is the auto scale functionality. Now, last year when I did the scaling to 256 instances, the main thing about my demo was that I had this slider and I manually scaled up my application to 256 worker roles and then scaled it down when I wanted to actually reduce the capacity. So I've actually configured, and this is in preview mode, the auto scale functionality in this particular application. So, and what I've basically done is say, okay, we've got a minimum of 1 instance, we've got a maximum of 5 instances here. I'm currently using one other instance, so I've got basically 6 cores available in this account. I'm using one other core for something else, so I can go up to a maximum of 5. I'm basically listening in this Alan Small data, which is an Azure account that I'm just using for testing on that particular set of articles. The queue name I'm listening to is the wiki transaction jobs. So the target number of messages in that queue per machine, I've set that fairly low and I've set it to 10. I've set the scale up to 4 instances at a time and the scale down to 4 instances at a time, and 5-minute intervals between those. Now, the reason I've done those settings is I want it to quickly scale up and quickly scale down during the actual session that I'm presenting. So I've got about 30 minutes to do that. So I don't want these scaling up one at a time. I want, the extra 4 machines and then it to remove those 4 machines. So one of the things we'll be looking for is in the instances section of this portal is how the actual if I go to the instances section, how this actual cloud service reacts to me placing those 300 odd messages on the queue. It should detect that there's a lot of workload here. It should then add more instances to my deployment. It should process all of those jobs, and once those jobs have been processed, I should get my application automatically downscaling back to 1 instance. And hopefully we should see that process taking place. So a bit about the actual process itself. What I'm doing is the basic website that you can go into and actually view the data is very, very simple. I've got a Windows Azure website here. I've got the text index table here in table storage, and this is the table that contains 1 billion rows. And I've got a blob storage container, and the blob storage container contains 4.3 million blobs. Each actual page content is a blob within that particular container. Now, when I thought about designing the query to be able to do efficient queries, if you've got billions of rows within table storage, you really need to think about how I'm going to query that data. What's going to be the optimal way to query stuff? So when you go in the search engine, you will type in a word or you'll type in a combination of words, and you expect to have the most popular search listing listed at the top, the most relevant listing listed at the top. Now, I'm taking advantage of a feature in table storage, which is the fact that the items within a partition are basically stored in order of the row key. So a quick refresher on table storage. The partition key is basically governing whereabouts that entity is going to be located. So entities within the same partition are typically grouped together. The combination of the partition key and the row key is used to uniquely identify that item. Items in a table are sorted by partition key and then by row key. So one of the things that you can do is you can basically get a unique entity by querying, saying the partition key is this and the row key is this. Give me this unique entity. And that's a very, very efficient query. Another thing you can do is query on a partition. You can say, give me all the entities from a particular partition. And you can also limit that. You can say, give me the top 100 or the top 1,000 or the top 50 entities from our particular partition. And when you do that, they're going to be sorted by the row key. So as well as, using this for uniquely identifying, the sorting is also a good functionality that we can use there. So what I do when I'm basically creating these tables is I take the number of the actual count of the word that appears on the page, and I basically take 10,000 and subtract it, and then I drop in the actual page ID. So this is what the actual table looks like in the big data example with 1 billion rows if I query for the partition key being equal to Azure and I take the top 10 rows. The row key there is basically saying 999604. So the article here, which is Capitaine Amoral, basically that will have, what is it, 473 instances of the word Azure appearing within that article. Windows Azure, which is appearing down here at number 5 in the search. You can see this is 99913, so there's going to be 87 occurrences of the word Azure in that particular article. So I've made a very simple text search. Basically, currently it does not support doing multiple items. In the text search, you can only search for one word. Also, the relevance filter is based on the actual word count of this, how many times this word appears in the article. Now, I could spend time, building a more sophisticated algorithm. I could, add functionality for multiple words and think about, how to get the relevancy better. We maybe want Windows Azure appearing, higher up the list and Azure the color appearing higher up the list. But the exercise was really to look at big data, not look at text sorting algorithms. There are better ways to do this, using proper search engines and other technology. I think the Lucene search engine can work very well in Azure and give great performance if you want to do that type of stuff. Okay, so uploading, getting the actual data into storage. Now, when you start working with big data scenarios, the heavy lifting involved in just taking that data volume and putting it into the data center, into Azure storage, can start to get challenging. So we need to think about ways that we can do this efficiently. One of the things I needed to do, or the first thing, was I needed to take these 27 XML files that contain these 4.3 million articles and actually upload them and get them into blob storage. I'll talk about techniques for doing this. One of the things that you want to be doing is making these requests in parallel. So the parallel libraries that we've got now in C# are very good for that. Also, being able to tune and customize, and we'll talk about that later, the way that the actual blob API, the storage API, actually interacts with the REST interface and does multiple thread requests. We can do a lot of tuning there. So that's the one task that I've done, and I've already done that in my particular scenario. So creating the actual indexes and creating all of the actual files for this, what I'm basically doing is I'm taking these 27 XML content files and I'm basically passing the page text, and I'm generating actual text files which contain chunks that can be inserted into actually build up my index. I'm also generating a list of pages with the page IDs and the page titles. Now, in order to get an idea of why I'm doing that and how this works, if we go into the actual dump section in the Wikipedia, into dump and into the actual transactions, you can see here I've got, if I select all of this data, 378 of these files, and that was just on the actual, the first XML file. Now, when I did this on the actual full content of Wikipedia, it generated 19,277 files, and these are basically the jobs. Each one of those files is an individual job for the worker roles, so there's about 20,000 jobs that the worker roles had to do. So let's have a look in one of these actual transaction files and basically see what's inside it. We can basically see that I really wanted to keep the data volume down. So what I've basically put in here is an actual word. I've got and this is really hard to read, I'll apologize for that, I'll just crack up the font. This basically has the word, it has the page ID, and then it has the actual count of words that appear on that page ID. So there is some profanity in Wikipedia. I do apologize if any of that briefly appears on the screen. So I'll basically have a look around and see if we can find anything that does have a high number. So we can see we've got the number 8 appearing on the word champion here. So this is basically saying that the word champion actually appears 11 times in the article with the article ID of 848. So that's basically how we're actually storing the word data. Now, if we go back and look in the actual dump and look at the actual list for the first pages, and just a reminder on that was 848 was the actual article ID, and we go around and look what 848 is, the actual article. So that's the Audi, basically has the word champion appearing 8 times. And if another article has it appearing more times, it will appear higher. We've got ABBA appearing down there, so that also is present there. We can go in and query for ABBA. And that will have, Sweden appearing a lot of times in that particular article there. So when I'm going through and doing these, the first time I looked at doing this, I kind of said, well, I take the first article, I do a word count, I get all of the word counts, and then I insert them into table storage. Now that would not have been very efficient. Table storage, we've got the option of using entity batch transactions. So the most efficient way in terms of performance and transaction costs to insert data into table storage is to use multiple transactions. These entity transactions allow you to insert up to 100 entities in one transaction, one HTTP request, provided that all of the entities are within the same partition, and provided that the entire entity transaction batch is less than a certain size. Now, because I'm using Word as a partition, I actually have to accumulate 100 of these actual items here before I've got a complete transaction. So when I went through all of these files, Andy's been talking about how we split up the data, we do all of the data processing. I basically did it as an in-memory operation where I read the first article, I got all of the actual word count from that, read the second article and got the word count from that, and the third and the fourth and the fifth. And when I got to a certain number of articles where I would have, a word where I had 100 references, where that word had appeared in 100 articles and I had the actual word count, that was one complete transaction. And when I got 1,000 complete transactions, I basically saved out these text files. So this means that these text files can be inserted quite efficiently into table storage. Each one of the larger ones basically contains 1,000 rows, and each row contains 100,000 transactions. So this is going to be each one contains 100 entities and there's 1,000 rows. So there's 100,000 rows that will be inserted into storage in 1,000 transactions. Now, as we go down and look at the towards the tail end of these files, you can see they're all around 695K. When we get down towards the smaller items, when I've basically completed batching out all of the ones that have 100,000 in them, there's all of these kind of words that are basically maybe combinations of letters or bits of URLs. I kept those in so I could get the billion entries. Is anything funny appearing on the screen? Yeah, but these are basically just basically cleaning out all of the partially completed transactions and saving these guys down. So not everything is being inserted in batches of 100, but there's other inserts there. So the process to insert within the blobs themselves, once these actual files have been put into blob storage and the messages have been put onto the queue, is to basically load up the words list. So the first thing the worker role will do, and in this case it basically loads up this list of words, so it's got the link between the actual page ID and the page title, and then it basically goes through each of those transaction files, takes the first line, gets 100 rows, inserts those as a transaction, the second one inserts that as a transaction, and basically goes through and batches those into a table storage. So hopefully that is what's happening now. If I go to the Azure portal, you can see that I've now, without touching anything, without doing any manual scaling, I've now got these 1, 2, 3, 4, 5 instances running and processing my transactions. One thing that I'm really keen about, and I learned this last year through doing all of the work with the animation rendering, is thinking about what's happening with our worker roles. So going into the tables, if I go into the Alan Small data, I've got this wiki role lifecycle table, and this is basically showing me the instances that I've got running. Some of these guys have stopped from my previous test, so I will go in and just delete those 5 entities there. And so that the actual 5 entities that we've got running corresponds to the actual 5 worker roles that we've got running. Now, this is basically showing that the first worker role we had deployed, it's been running for 1,689 seconds. It's processed 40 jobs. There's the actual server name with RD, which stands for Red Dog. The other instances that have started there, they've basically processed 7, 8, or 9 of these transaction jobs. And if I query this page and do a refresh, you can see these being updated, showing how many jobs, how many seconds running they've been doing, the actual status, the number of transactions that they've run. You should be able to see the number of, maybe it hasn't, yeah, the number of actual rows that have been inserted in the table, and also the number of transactions per second that that particular instance is averaging at. Now, when we did the global render lab for the Global Windows Azure Bootcamp, I used exactly the same pattern. I think we had 10,000 worker roles actually got started and decommissioned. At one time, we had 4,500 worker roles running. And how we got the actual, score counts for the various countries and showed, that Denmark was ahead of Sweden and all this type of stuff. We basically were basically querying on this table, looking at the number of frames that had been rendered. Now, the reason I use this, the reason I recommend this pattern is you're paying for these compute resources. So you really want to know, I'm paying, so much per hour to run each one of these instances, or so much per minute. If I can figure out how much work these instances are performing per minute and how much I'm paying for them, I can get this down to a number of, transactions per dollar, which is really what the business people are interested in. You can get a really good cost analysis on how you're using those particular resources. So I don't know if this is complete if I query this. I think there was 300 and something items here that had to be inserted here. So you can see this is basically running at maybe about 100 I've got inserted. I've maybe got 200 to go. Another thing that I do is I basically start monitoring the worker roles. And I really want to know what's happening in those particular worker roles themselves. Now, what I'm doing here is basically this is listening to a queue. And we did the same thing with the Global Windows Azure Bootcamp. We had, at one time, 4,500 worker roles running. The worker roles, if there's an exception, if there's a problem, they will basically write the exception details to a queue. And you can sit here with this one console and just basically have a simple way of monitoring what's going on, and if anything happens in any one of those thousands of worker roles, you can basically see the exception occurring. I'm also checking, I've got a number of exceptions and exception counts. So this is if I get any failures when I was doing my actual batch processing, I will see a number of exceptions appearing on that particular worker role. So having an understanding, gaining insight into a process that's running on a lot of servers in a data center is going to be a key. With this auto-scaling, I mean, the traditional thing about, something goes wrong in your server, you go and look in the Windows event log. Now, if you've got auto-scaling, you could have an instance that was created, it did some processing, and it was destroyed. So the Windows event log for that machine doesn't exist. The machine has been destroyed. So it's good really to archive and have good ways that we can actually monitor that data. So that's basically what we did when we created the data. I've talked about what the index files contain, and I'm looking at the inserting. So the transaction files themselves on the the real process, it was the 19,000 transaction files got put into blob storage. I put 19,000 messages on the queue. I used 6 worker roles to actually do those inserts and do the insert to put those billion rows into the actual table storage and get that data. So this is another thing that you should think about carefully if you're working with table storage, and it's basically monitoring the actual process and gaining some understanding of what's happening, what load you're placing on the resources. The portal provides you with these graphs, so you can basically turn on storage analytics and it will start storing data about the transactions, the amount of data you've got stored, and you can basically get these nice graphs. So you can see here that this started probably partway through the day on August 26th. It finished partway through the day in August 28th. So it's probably about sort of 50 or 60 hours it took to actually do that full insert into table storage. And you can see for the requests that were running on the queue, on the table and on the blob, the actual amounts that we've got here. So basically we got a large amount of requests on the queue. That was basically, this is per hour. So that was when I put on the 18,000 messages onto the queue, or the 19,000 messages onto the queue, and it started processing those. That's why there's a spike there. It then went very, very smoothly, running through the majority of the actual items here. And when it got to here, this is when it finished processing all of the transactions files that contained 100,000 entries, and it got onto the transaction files that contained less entries. So the speed at which it was doing the requests onto the table and onto the blob increased there. You can see the actual peak per hour onto the table is, was it 2.3 million requests per hour on that particular table. Now, as we were talking about yesterday, the scalability targets that we've got on Windows Azure, it's something like, I think it's 20,000 transactions per second per storage account. So I'm getting nowhere near the actual, scalability targets that we've got on the storage account there. And we'll talk about those a bit later when we talk about, what's happening with the site. So storage analytics and analyzing this data is something that we do have to think about. So a few tips about working with the actual data and working with large table storage. The way that the billing works and the way that the transactions work, also the way that latency work, is going to be something we think about. Now, when I started prototyping, I was running on-premise. I had my actual desktop machine running at home, and I was running against Windows Azure storage. And the performance when I was basically running the uploading of all of my blob data was pretty terrible. It was taking something like a week to actually insert all of the Wikipedia articles into blob storage. So one of the things that you can do is, instead of actually having real hardware on-premise or virtual machines running on-premise, you can leverage the Windows Azure virtual machines and start downloading and doing the processing of your actual data, running very close in the same data center. This gives you so many advantages. The first advantage is it's very inexpensive to create a virtual machine for a short period of time. If you want to spin it up for a few days, it's very easy and quick to create those machines. Secondly, the actual latency that you get between the actual process that you've got and the data store is much less because it's in the same data center than it would be going from your actual particular location. Thirdly, data egress. You get charged for data that is leaving the data center. So if you're querying lots of data or downloading lots of data, or you want to do lots of analysis, or you got a lot of network traffic, if you're doing that on premise, you'll be getting billed for the data that's leaving the data center and coming down to your servers here. So running with these actual machines in the cloud is a much better way of doing things. And that's what I did. I basically span up a Windows Azure virtual machine. I downloaded the Wikipedia content onto the hard drive of that virtual machine and basically ran all my processes from there and tested everything. And I got much better performance by doing that. A really good site. This came round, one of the Azure insiders built it, the Azure Speed Test at azurewebsites.net. And this is really good for looking at different sites, different performances. So I've got this website here. What this website does is it starts up an actual web page. It then starts making blob requests out to all of the Windows Azure data centers, and basically comes back with statistics over what the latency is to the different data centers, and basically builds up a graph. You've got to leave it running for maybe half a minute for it to get an average statistic here. But what we can see here, that if I'm wanting to choose a data center where I've got low latency, you can see that the average going out to West Europe is 91 milliseconds. Southeast Asia is 292 milliseconds. So thinking about, where should I go with my data? It may not be the closest data center, but the actual one that's giving us the low latency. We're now down to the average of 86 milliseconds versus 126 milliseconds. So there's quite a good advantage of me going to West Europe rather than North Europe in terms of the actual latency against those particular storage services there. So definitely worth bookmarking that site and using it when you're working with different customers. Obviously, if you're based in Dublin or based in Amsterdam, you're going to be getting much lower latencies going on those data centers. If you're lucky enough to, I'm looking at these two guys from Helsinki. If you're lucky enough to live next to a Windows Azure data center, you're going to get much different performance here. So we were joking when Mark Brown was coming out with, he says, the speakers at Cloudburst, do you want sharks with lasers t-shirts? And we're going, yeah, of course. And he's saying, what size? And we're saying, small, medium, large, extra large. And some of us were joking and we're saying, well, we want A6 or A7. Now, in the early days, last year, Windows Azure was offering the virtual machines and the web roles in worker roles, and I describe these as t-shirt sizes. You can have extra small, medium, large, extra large, and you pay basically based on the number of cores, but everything is proportional. You've got this with 8 cores, with 14 gig of RAM, and everything basically, is going to be 2 times bigger going up here. It's just basically taking an actual physical machine and dividing it up into chunks and taking a certain chunk, a quarter or an eighth or a half or the whole of that particular physical machine. That's okay if your actual requirements basically match what's happening with those actual machines. But there's other requirements that you could have. You could want to have a large number of processors, but you don't need that much memory. And you're stuck with going, today with the extra large instance here with 8 processors, and you're paying for your processors and your memory. And you could have scenarios where you want to do lots of in-memory processing, but you don't really need a large number of processors to do that. Now, the A6 and the A7 instances are really starting to address that, and it's kind of a bit more like gene sizes, where you go for the waist measurement and the leg measurements. You've really got 2 things that you're considering here: the memory and the actual processor core. I hope that this is going to change in the future. We're going to be have a lot more selection here, where we can have 64 cores and not that much memory, or have tons of memory and 8 cores. But a couple of the things that are very useful, I actually use the A6 instance here with 28 gig of RAM, because I tried actually running that in-memory processing with the transactions at home, and it didn't work too well because I was running out of memory and doing disk caching. But with the 28 gig of RAM, that was actually working a lot better. The A7 has 56 gig of RAM, so when people talk about big data, they say if you can load it into memory and process it in memory, then do that, because it's going to be much, much more performant. So if you want to do a big data processing and a big data operation, it's kind of like, going to your boss and asking for these big storage systems. Going to your boss and asking for a server with 56 gig of RAM, it's going to be quite hard to actually get that acquisition, especially if you only want it for 2 days to do some basic processing. Well, here, you can create that instance with 56 gig of RAM, keep it kicking around for a few hours, and then just delete it, and you get charged per minute for those virtual machines. So that's really good. The only disadvantage that I found with the Windows Azure virtual machines is if your data processing is file heavy. If you're making a lot of access to files on the hard drive, you're probably better off doing that on premise with actual physical hardware than running on the actual machines in Windows Azure. But as far as the costs, the processing, the memory, the speed to get things provisioned, the actual really quick access that you've got, low latency access to the actual storage services themselves, the actual virtual machines are a very good option to go for. Performance tuning. I'm a Formula 1 geek, so it's the Singapore Grand Prix that's starting today. I'm also a Lewis Hamilton fan, so I'm going to be really interested to see how Lewis is doing. It's getting towards the end of the season. I think Vettel's going to run away with it, but Lewis has been doing pretty well, and it's going to be interesting to see how this continues. Every time they go to a Formula 1 track, they basically tune the car for that particular track. And because I follow Formula 1 a lot, you can see that the rear wing there has quite a steep angle on this. So that's providing a lot of downforce, which is pushing the back of the car down onto the track, meaning as they go around corners, the back end doesn't slide out. However, when you're going down the straights, this actual wing here is causing a lot of drag, which means it slows the car down. Red Bull have been so dominant for the past few years. They actually have the slowest car, well, one of the slowest cars in the actual speed traps. They generate so much downforce. It's all about tuning. And we've got various options for being able to tune the way that our machines run against Azure storage and be able to make those performance tunings. And just like going to different tracks, for different scenarios and different network topologies, the tuning is going to be different. There's going to be some general things that you need to understand, and you really want to be thinking about how we tune for those particular scenarios. So one of the things that we do need to change is we need to start working with the Service Point Manager class. You've sometimes had this when you're in Windows Explorer. I had it when I was downloading the Wikipedia files. You download a file, you download the second file, you download the third file, and it doesn't start downloading because the actual process is limiting the number of concurrent HTTP requests. Now, if you're wanting to do lots of stuff in parallel, the Service Point Manager can sometimes have a default connection limit of 2. So if you're doing loads of parallel processing, that isn't going to help you much. So as your process starts up, you need to set that actual connection setting to something other than something greater than 2, 100 or 1,000. When you create a file new project and you add a worker role, you'll see that the Service Point Manager.default connection limit is set to something like 16. So you can do more processes accessing the storage through HTTP requests. So that's the first thing that you will need to set. Now the Nagel algorithms and the accept 100 continue, I don't know too much about how those work. I've not tested those. I think the Nagel algorithm is related to short HTTP requests. Not too sure about expect 100 continue. I haven't really experimented that much. But you do need to think about what you're doing with the service point manager. Another thing we need to think about is the way that the storage API interacts with the REST interface. Now, block blobs and page blobs, you may have read something about this, how you do have an option to manually go in, and you can basically choose to start uploading loads of blocks, and then you can commit all of the blocks in a blob and actually create the blob manually. Or you can just basically allow the storage API to do all of this for you. And if you're basically using Fiddler, this is what you see. You upload a small or maybe a medium-sized blob, and the blob is uploaded in one single HTTP request, like this. You go up with a slightly larger blob, and you look in Fiddler, and you see this. There's a sequential set of blocks that are basically uploaded, and then you've got this actual shorter request, which is the actual block commit, which says, okay, take all of these blocks and actually commit them to a single blob. Now, it would be much nicer if this happened. That will give you much better performance because you're basically making parallel HTTP requests up, and you can actually commit that blob a lot quicker. Now, the default option will be to actually send up these blocks sequentially, but we've got some control over this, and we can tune these various operations. One of the things we need to be aware about is the single blob upload threshold in bytes, and that basically says how many bytes you've got, and I think it's 32K is the actual default, before the actual storage API decides that this is a large blob and basically starts to split it into different blocks. You've also got this stream write size in bytes, which governs the actual size of those sequential blocks that are going to be uploaded. Probably the most important one is the parallel operation thread count, which tells the actual storage SDK to actually upload these in parallel. The default value is 1. The maximum value on that is 64. So when we're thinking about tuning the blob operations, these are basically the settings. We've got Cloud Blob Client, which has the single blob upload threshold in bytes and the parallel operations thread count there. You probably definitely want to start changing this for uploading large blobs. You maybe want to think about changing this, but tune it based on the actual scenarios that you've got. And then on the Cloud Block Blob class itself, you've got the stream write size in bytes. I think this is actually for a page blob. That's an error. You've got the stream write size in bytes there on the actual page blob and these various defaults, and you've also got this setting here. So the ones that I've been experimenting with is these two and this one here for doing the actual uploading. You've got the various different settings that you can set those guys to. I'm just going to take a quick look back and see what's happened in the actual scenario. So I'm going to go back to the site, and you can see here that I've got the actual one instance running. So those extra 4 instances that I had have basically now been removed and decommissioned, and I'm back down to 1 instance. And the reason why I like doing this lifestyle role tracker is I can basically see that an instance was created, it was running for a certain period of time, and if I refresh, we should hopefully see that these 4 have actually been transitioned into the stop state. But those machines are gone, they're disappeared, but I do actually have the statistics about how many seconds they were running, how many rows they inserted, how many actual jobs and how many actual exceptions were thrown on that particular machine. So it's really good to monitor that stuff, especially as I mentioned, this scaling stuff is in preview. So if you go to the scale section, there is a graph that should give you the number of instances that you've got running, and currently there's a slight bug in that graph in that it's really basically showing 5 instances completely here, and I had 1 instance and then scaled up to 5 and went back down to 5. So this is in preview. That will be fixed hopefully in the near future, so we should get good statistics about how many instances we've actually been running. As somebody mentioned earlier, I really like the idea of this auto-scaling. I think it's great stuff. And I was talking with a customer a couple of weeks ago, and they were kind of thinking, well, auto-scaling, is that going to cost us a lot of money by ramping up loads and loads of servers, and we don't have control over how much it's ramping up. You've got a lot of control in that you can set the maximum number of instances. This is about reducing cost. Think about last year. I was doing my demo where I was spinning up 256 roles. I was joking with the audience and saying, you know, this is a $30 demo, and if it basically runs over the hour, it's going to turn into a $60 demo. My worst fear was that you know, I'd finished doing my conference session at the end of a conference, and they basically switch off the Wi-Fi network, and I would have 256 worker roles running, and I'd have to get to the airport, and it would be costing $30 an hour on an Azure account, and I'd have to go in and find a way of shutting it down. With the auto-scaling, you know, we've also got the billing, meaning it's we're being billed per minute. So my $30 demo is going to turn into a $10 demo with the per minute charging and with the actual auto-scaling capabilities. It's going to save money, this stuff. I'm looking forward to this stuff being available for general release, because it's great to be able to leverage this functionality. So uploading blobs, you've got various options for using parallel actions. You can basically upload the blobs in parallel themselves. And that's basically, you know, leaving the option on not touching the actual SDK and telling it to do the blocks in parallel. You can also, if you've got one large blob, basically upload the blocks in parallel and have parallel uploading. That can give you some good performance. And you can do combinations of the two here. There was a great presentation. It was at Build or TechEd where they talked about different scenarios. There is a scalability target of how many transactions you can run on a particular blob, and you may go above that scalability target. So doing a combination of both is going to give you a good performance when you're doing those uploads. So think about how much this stuff costs and how much you're going to be paying, how much you're going to be getting invoiced and all that type of stuff. You really want to keep control on that. Now, the portal does provide you with these graphs. This is coming from when we actually ran the global render labs. So we pushed the queue storage up to 2 million transactions per hour running on the actual queue storage. That was about 580 transactions per second that were running on the actual queue storage. And when you think that it's 10 million transactions for $1, this is basically costing about 20 cents an hour to maintain this actual level. Now, these graphs are okay, but you can do a lot better than that by looking at the storage monitoring tables. Now, in a storage account, when you turn on storage analytics, these tables will be created. They're like hidden tables. They won't appear in the Windows Azure Storage Explorer, but they won't appear when you do list tables, but you can go in and query those tables. This is something that's evolving, and I'm really pleased to see it here now. I really look forward to seeing it evolving. We've got metrics capacity blob. I can see how much is in the blobs, and we've got metrics transactions for the blobs, the tables, and the queues. So let's have a look at see what happens and what we can do with those guys. So what I'm going to do is I'm going to go to File, into the Projects and Solutions, and bring up this Storage Analytics project, and this is basically going in, and I'm going to run this and get back some statistics. The network here, it takes quite a long time to actually initialize the connection and get the actual first request coming back, but we should be able to see some useful statistics coming back on this. Again, this is kind of like I build my own you know, role tracking because I want more details on the roles. This is basically querying directly onto those tables. I haven't had to modify the code in any way to get this data, and it's showing me information about what's happening here. It's pretty hard to see, so I'll see if I can I think I just paste it into Notepad if I can do, yeah. So the first section here, I'm querying the actual transaction tables, and the graph really shows a bit of data, but you've got all kinds of stuff. I'm basically showing about a third or a quarter of the number of actual metrics that we've got in that particular table. So there's all kinds of stuff: the total ingress, total egress, the actual availability, the average end-to-end latency, average service latency. And what might be interesting is to have like the number of errors, like the client timeout error or the actual throttling error, and so on. And these actual errors is going to be interesting when you're thinking about processing. Also, and several people have mentioned that, think about transient fault handling. I was noticing I was getting some throttling errors, some client errors, and I was thinking, well, I've got errors, but I didn't get any exceptions in my code. Why was that? All my data has been inserted, but I am logging errors here. So the built-in transient fault handling in the storage SDK means that you may get a transient fault and the storage SDK automatically does a retry. But these will be logged and recorded as errors here. So all your data will have inserted perfectly, but you will see that the actual service did get errors, but the transient fault handling handled that. So you can basically look at the pricing, and this was when I did my insert. It's like 20,000 transactions at 10,000 transactions, sorry, 20 million transactions at $10 million. So that's about $2 to do my insert. And then we get into the actual blobs and looking at how much it's costing to store the blob data here. So this is basically done per day. The transaction stuff is done per hour. And you can see on these particular days, this is basically saying here on the 20th, we had 6 containers. This is how many blobs I had with the article content, 33.7 gig. The daily cost on that is just about 10 cents. And here's the actual total cost that I've got for all of the actual days in storage there. So if you're in a multi-tenant scenario and you want to send all of your tenants a bill, all of your users a bill at the end of the month, this is really great stuff to be able to leverage. It is currently on per storage account basis. So if you've got 10 blob containers, I've got 6 containers, I can't easily see how much I've got in each of those actual containers there, but I can get an overall a value for that account. So if each of your customers has their own storage account, you can leverage this stuff to be able to do really good billing to those actual customers. Even tell them what the actual availability on their storage has been, how many transactions, and add a bit on for yourselves to make some money, and basically be able to actually send them a bill that represents how they're actually using those particular scenarios. A bit about query performance. So if I go into the previous project again. Now, when you query the data, it's really important to do efficient queries. So I'm going to comment out these two guys, and I'm going to comment in this query test times. Just run a control F5, and this is going to run a couple of queries. The first query, I'm going to be querying on where the actual partition key, where the actual word is equal to a computer, and that's basically doing the get top 1000 where partition key is equal to this, and that is taking 0.05 seconds, about 580 milliseconds here. It's now querying by page title. And this is basically going through and saying select from the actual table where the page title is equal to such and such. And the page title itself, if I go in and look at the actual results in the table, which is this text index, I'll just basically query off 100 rows off the top of that table. The page title there is basically not indexed, so it's a very, very inefficient query to run here. And you can see that it's still running away. I think it will be about 30 seconds to run that query, so we do need to be aware of how efficient it is at doing those scenarios. So how am I doing for time? About 5 minutes or something? Yeah, cool. I'm not going to wait for that query, it's taking too long. I did actually run and I tested the query on the large one with 1 billion rows. This one's got a couple of million rows in, I think, and I started it going partway through Andy's session, and 45 minutes later it hadn't returned the actual result yet. So, not doing inefficient queries on large amounts of data is just not going to work in storage. One thing you do need to be aware of is outages. On 29th of February, there was a major outage of Windows Azure due to a certificate error. We do need to think about these because this is going to happen whether you've got your own data center, whether you've got your own hardware, whether you're building your own systems or looking after them themselves. They don't happen very often, and whenever an outage happens with a cloud platform, it's kind of like some major event. You remember where you were and you remember exactly what you were doing at that particular moment in time. We remember this because we were out at the MVP Summit 2012, which was running from the 28th of February until the 2nd of March. So we remember this vividly in our memories. 22nd of February 2013, we had a storage outage, this time also due to a certificate error. And remember where we were during that time, because we were at the MVP Summit in 2013. There's a second MVP Summit this year, November 18th to the 20th. So if you are superstitious, Yeah, so do be aware of outages. You can think about, using multiple data centers. You've got your geo-replication. You can even, use Azure and Amazon as cloud, two different providers to be able to, give you the things that if something goes wrong with Amazon, like it does occasionally, and something goes on in Azure, you've got the backup. So you do have scenarios of being able to build highly resilient systems that go above the SLAs that we've got in cloud providers. So a few more things on these. I think I've covered most of the stuff talking about these. Think about handling transient faults. Another one, download the source code for the Windows Azure SDK, which is available on GitHub. I've learnt a lot from looking through the code and also looking through the actual, there's extensive test code that they've written. There's a whole series of, I think there's 500 and something unit tests. So you can look at the unit test code in the storage SDK to see how to call a certain method, how to call a certain function. That's really worth looking at. Okay, I'm going to sign off, but what I'm going to do before I go is actually show you the URL and show you the actual site that is running with those billion rows in table storage. So if I go to Azure Wiki, and this is the wikisearch.azurewebsites.net, and I'm going to search for Azure, and I'm going to click on search. And that's basically doing that query onto the entities there. And we've got a billion rows in that table. But when I do a repeated search, as you can see, it's coming back with 1,000 results in 414 milliseconds. If we go for Microsoft, run the query, 577 milliseconds, and that's bringing back 1,000 rows. That's querying off a billion rows of data. I was surprised how quickly that is. And you think about the costs of doing this. I think... did we have it in the costs? It was for actually storing the blobs. I think it's about $2.30 a month or something for the actual storage cost for the blobs. It is not expensive. So lastly, and this one's, we've been interacting with the audience here. I'm going to interact with any online viewers if we've got people watching. So I've actually set up Google Analytics on that particular site there, and you can see the actual world map on here. If I drop up this URL, this is the actual URL. Hopefully you can see that if you're online. Please go into wikisearch.azurewebsites.net, actually play around with that, query some data, and see what types of queries you're getting. It is available publicly there. And if you do that, we'll see your country appearing and where you are located, and it's going to be fun to watch as we have our coffee break here. Thank you very much for listening.